Good morning, my dear students. I hope you might have enjoyed the first semester of our prestigious environmental technology program. In this semester, I like to introduce you a new and innovative paper, ENB 2208 Environmental Modeling. So regarding this course, I have to tell you something very clear, what is meant by modeling. You know, environmental system is a rather complex system. It consisting of all natural, physical and chemical and biological process going on in the nature. But you must understand that all the creations and all the activities going on in this nature are the true manifestations according to a mathematical formula. Suppose a human body is originated from a mathematical rule designed by the nature. A person is having a single head and he is having two eyes, he is having two legs, two hands, and on each hands he has 5 fingers. You imagine that the mathematical principle behind all creations. Similarly, the importance of mathematical modeling. When the mathematical modeling principles are applied into environmental system, the subject is defined as environmental modeling. I have learned this subject from the famous environmental modeler and famous environmental biotechnology Professor Mark van Lutrek of Technical University at Delft as a part of curriculum development, and I was inducted into that program as a postdoctoral trainee in the year 2002 and 2003. In this course, I will tell you what is meant by a model and what are the principles behind mathematical modeling. What are the systems, reactors, etc. You know, all the activities going on in nature can be defined into two systems. Either it belongs to a reactor system or a tubular system. The reactor system means it can be a unit operation system in which a process is going on according to a definite volume, time, and etc. In a tubular system, the concentration is remaining constant throughout the length of the system such that the process undergoes as per a definite concentration gradient. In a normal reactor system, the concentration remains constant. So, starting from this simple concept of the nature divided into a simple reactor system or a tubular system, we can define all the process in the nature according to a mathematical principle. The mathematical formula applied to describe all environmental phenomena are known as a mathematical model. That mathematical model tried upon to study the physical systems and biological systems according to environmental concept is known as environmental modeling. A model is nothing, it is an abstraction of reality. A model never be a true representation of reality. That is the basic introduction to this subject. In this paper, you will study different aspects of modeling, the simulation, what are the simulation tools. All the phenomena can be simulated according to a mathematical rule so that the complexity of learning the natural systems can be simplified, the energy, time and money can be saved. Suppose a wastewater treatment plant in which the primary treatment occurs, secondary treatment occurs, tertiary treatment occurs, finally the effluent is going out. But the regulation, as per the statutory regulations, if the BOD or COD is not in conformity with the prescribed level, then we have to optimize the process. For optimization studies, we have to depend upon the pilot plant testing. For trying the pilot plant testing, lot of energy and time is required. But we understand the process, the chemical phenomena, the kinetics, the mechanism going on, the mathematical principle behind it. We can design the process using the softwares. We can do the optimization process using the softwares. The simulations can be done so that the optimization process can be simplified, the time and energy can be saved. This forms the simplest application of environmental modeling. Imagine a riverine system, especially all of the Cochin city is getting the drinking water as well as the water for the domestic purpose, for the industrial purpose from the Periyar river. Imagine how the river Periyar is originated. What are the complex environmental and natural recirculation phenomena are involved in the purification, the natural aeration and purification, as well as the flow dynamics of the Periyar river. We can divide the entire length and strength of the Periyar river into small compartments into the form of a small reactor or a tubular reactor. The phenomena going on each section of the river can be studied such that the entire complexity of the river chemistry can be studied. This is another application of environmental modeling. Same time, the Vembanad lake system. Vembanad lake system can be a simple reactor. It is having just like a waste holding tank. The water is coming into the tank, water is going out of the tank, in which the freshwater input is given by the Periyar river and Muvatuvizha river, recirculation is going on, industrial waste undergoing the mixing process. According to the tidal effect, the water is given out to the Arabian Sea. So this dynamics, on studying the dynamics, all of the economic engineering of the whole of the Cochin city can be studied. This is another application of environmental modeling. Environmental modeling can be applied to simple systems, the studying the biological phenomena going on the bacterial cells, such that the biophilic models can be studied, the monod kinetics going on in all the microbial cell activities can be studied. So this activity, when it is applied through the mathematical situations and the simulation process, we can study how the biological chemistry can be utilized for industrial and wastewater treatment. This is the basic aspect of environmental modeling. Thank you very much.